All right, it's finally done. A working flight sim in Minecraft with just Redstone. It took a minute to build. I think I started this about 6 months ago. So, elephant in the room, I'll be the first to admit that the end result is kind of underwhelming. I feel like for all the effort to do this, you can barely tell it's a flight sim with the screen resolution. But this was never really about the sim and much more about finding something to showcase this new concept of a color display. The reason I chose the flight sim was because I knew that latency was going to be a major issue. It takes about 3 to 4 seconds for the user input to propagate all the way through the machine and update the display, just because there's so much going on. And I figured a flight sim would be a bit more forgiving than something like a side scroller. So let me show you how it works. This world is available for download in the video description, but a few things to note. It's very resource intensive. My laptop can barely keep up, so you should allocate at least 6 gigs of RAM to Java if you want to try run this, and keep your render distance low if you don't have a big gaming rig, otherwise it'll just choke. When you download, you'll spawn in here. Note that in order to not see the TNT explosions in vanilla, you need to change your graphics settings to fast. This will mask the explosion particles when you look through stained glass like I have set up here. To start the machine, throw a snowball in this direction, and then you gotta wait about 20 seconds. And during that time, the screen will initialize by dispensing some buttons into your inventory. And that's basically to shift the colors. You'll see here in a sec. Yeah, see how the colors aren't assigned to the right sections? And then it shifts that so the sky is blue, the grass is green, etc. And it'll start the plane in a holding pattern on the runway. Now, to lift off, simply move backwards, and the piston will push you back into the center of this console. To turn right or left, just move right or left, and it'll bank the plane in that direction. And if you want to chain inputs, you need to wait about 5 frames before triggering the next input. Otherwise, it'll just override your first one. So for example, I'm flying straight. Now I want to bank right and then straighten out again. So I move right, count about 5 frames, and then move back to straighten again. And the plane will bank right by 90 degrees and then fly straight again. And to land, just move forward and the plane will land. It's barely a game. Like I said, it's just more of a way to showcase the different mechanics like the screen and the wireless data transmissions, etc. So to clear the screen, I'm using about 50 TNT per frame, lined around the perimeter as well as shooting across the front of it. As you can imagine, getting the right position for the TNT was tricky, since too close and it'll blow up the dispensers behind the shulker boxes, and too far away and it won't fully clear the screen. On rare occasions, I think once every few hundred frames or so, it might not clear one of these 3 center shulker boxes. And in that case, I built in a mechanic that you can reset those just by throwing a snowball at the glass in front of you like this. And so you'll see here, the machine now works to reset those pixels, and you should have a fully working screen again. To turn it off and reset it, throw a snowball back into this direction, and it'll halt the ROM and rebuild the machine. I didn't bother building in all the reset mechanisms. It's possible, but like I said, this is more meant to be a showcase, and I've kind of run out of time and interest for this project. So it'll clear the screen using a data pack and rebuild it, and you wait a few seconds, and then you should be good to start it up again. The ROM doesn't get cleared since it takes forever to rebuild, so I did build in reset mechanisms with Redstone for that part of the contraption. The ROM is good for a few hundred runs, so it shouldn't require a rebuild. For the world I'm putting up for download, I've actually built a smaller world to fly around in, simply because the bigger the ROM, the more laggy the game gets, and so I was trying to find a balance there. In this case, the ROM alone still fills up about 70 million blocks. I've tested it all the way up to 250 million, which used to be the spawn chunks, which are now gone. So I'm just using the force load command to keep the right chunks loaded for this to work. Similar to my chess computer, the way the functions work is by cloning all the various components I've got in this world and then piecing them together like a puzzle to make the final machine. Okay, so how does this all work? At first it seems a little like black magic, so let me walk you through what's going on here. So the shulker boxes are obviously dispensed by dispensers, And then, like I said, the TNT is what clears the screen at a rate of 2.5 hertz. So each frame lasts 4 redstone ticks or 8 game ticks. The reason you don't see a flicker is because of the order in which the game processes everything. So you can see when I step through here, you'll notice there's one game tick where everything's cleared and the next frame hasn't been dispensed yet. And then on the next game tick, the shulkers get dispensed. But when you run the game normally, you don't see this empty frame, which allows for this kind of seamless playback effect. The challenge comes from when trying to make this screen interactive. A while back, I posted a video of this screen just playing back preset frames, and that's pretty trivial. You just stack a bunch of droppers and hoppers and cycle the frames down. But to make it interactive, I had to have a way to create shulker boxes based on the user input, and I did that using crafters. This machine here is set up to use 4 different colors. You could probably design it to use more, but I tried finding the right balance of size and complexity. So based on which of these droppers receives a signal, it'll send up a colored die, mix it with one of the blank shulker boxes. The crafter makes the right colored box and then sends it down these dropper lines all the way to the screen. I noticed a while back that I wasn't going to be able to have regular transmission lines for the ROM because the lag was just increasing exponentially. You can check out the video series of this build that I made on my channel where I talk more in detail about all that. So I made the decision to switch to wireless data transfer from the ROM to the machine, but doing that meant I had a bunch of other issues to tackle. One of the biggest issues was I started getting pretty bad interference on the screen. There's a lot of good tutorials out there on wireless redstone, so I'll just do a brief primer here. Basically, a while back, 2know2name figured out that items share a global variable to vary their initial drop rate. Here's what that looks like. I've spawned in a bunch of buttons here in the same tick, and when I start dropping them, what you'll notice is that they drop in a wave pattern that repeats every 4 items. So every 4th item will start dropping in the same tick. The issue arises when you drop items through the air anywhere else in the world. It'll interfere with these precise readings that you're trying to do. And so initially the screen here would filter items down by dropping them through the air into a hopper below. So this strange setup you see here with the boats and all that is all in an effort to mitigate having to drop items through the air into a hopper. Basically, by having a hopper minecart partly in the block the item gets dropped into, it doesn't disrupt the global variable counter that we're using for our wireless data transmissions. And so I had to figure out a way to get the minecarts close enough where they could pick up the items above in the same block, but not too far away where they can't transfer that item to the hopper minecart below. That works fine up here. Using snow layers, you can slightly vary the height and minimize the number of hopper minecarts you use. Since they're pretty laggy, you want to keep that number down. But down here, the TNT explosions are too close, and so they kept destroying the minecarts. So to solve this, I found a precise height for the minecarts by resting them on boats tied to leads up here. There's one final gap I wasn't able to get rid of. To address this, what I did was configure the timing so that in the tick when items get sent over this gap, I don't actually transfer any data. Basically, each frame is 8 game ticks, meaning within 8 ticks I need to receive all the data necessary to build an entire frame. So that's 15 pixels by 7 pixels. So what I do is I send the data for each line in one tick. So tick 1 gets the first row, tick 2 the second, and so on. And that leaves tick 8 where I don't need to send any more data. And that's the tick I use to drop items over this final gap. I think a lot of this could have been mitigated by running it on a server. I think the server code handles the item counter differently, but I wanted to see if I could get it running on single player. Then came the issue of actually receiving this much data in a single game tick. To do that, I had to control the update ordering for 15 items dropping in the same tick in such a way that they wouldn't interfere with each other. We need 31 different update orders, and the shorter they are, the better, because each tick also adds to the latency from user input to screen output. So using different delay components that affect the update ordering, I was able to get 31 unique update orders that we could use in our receivers. Here you see a little engine running forwards, even though all these are powered in the same game tick. And if I were to break this by, for instance, reversing these two and now run it, you'll notice that it stops because the order was backwards. So testing this all the way through, we see the machine works for all the different update orders. And now over here, I've got all the wireless receivers set up. These are constantly dispensing items in the right tick with the right update order to receive the data that's being sent in from the ROM at the same time. Okay, the ROM. Let's talk about this monstrosity. The concept is pretty straightforward. You send a pulse down these lines and they dispense items into lava at the right moment with the right update order. I'll dispense 4 items in a single game tick. There's 1 detector item and 3 fillers. Using update ordering, I should then be able to define where the detector item is in the sequence by putting filler items either before or behind it, and that way I should be able to send 4 different color options for each pixel. All of the wiring up top is basically your plane moving through the virtual world. Essentially, when you start the machine, it sends a single redstone pulse to the ROM, starting the flight. I then keep this pulse alive by routing it around the ROM based on where your plane is actually flying. So each tower of this ROM is 5 frames, so every 5 frames, the plane can exit its current preset 5-frame video and enter a new one. This is how the ROM is laid out. I need to account for the plane flying straight in 4 different directions, north, south, east, west, making a right or left turn from any one of those flight directions, so clockwise and counterclockwise, plus land, hold, and take off. So this setup allowed me to cram as much data into a small space that still let me route the plane throughout the world. This way, essentially at any given point, you can land, you can hold position once you've landed, you can take off, you can fly straight, or bank right or left. I also designed the edges of the world to loop around so you don't hit a wall and instead just loop to the other side of the virtual world to keep flying. Then to control the plane, I just need these few input lines, and they route your input over to the whole ROM to direct the flight signal no matter where it currently is in the virtual world. One tricky part is I actually need 2 signals, one that's slightly ahead of the other because often you've got multiple places you can branch out to, and so I need to prime those parts of the ROM so that when the true signal arrives a split second later, it gets routed to the right place. One of the main reasons I did this was to decrease latency as much as I could. So instead of only being able to reroute the signal before it enters the update ordering line, I wanted to get as close as possible to the dropper. So I built in this mechanism where it essentially holds power to these droppers until the very last tick before the signal could reach them. That way I can have the whole system be much more responsive and get latency down. Anyway, I'm not sure if I explained all that very well. If you have any questions, feel free to ask and I'll try to answer in the comments. In the end, it was a fun project to try push Minecraft to its limits from a redstone mechanics perspective. A lot of the complexity really comes from trying to make this machine as fast and lag friendly as possible. So it was an interesting project trying to puzzle through all these things. Yeah, at the end of it all, yeah, like I said, it feels like the result is a little underwhelming for all the effort, but I guess that is not what it was ever really about. So I hope you guys enjoyed this project. Thanks for following along the series, those of you who did, and I hope it can serve as a little inspiration for everyone out there who gets joy from this game. Thanks a lot for watching. Take care.